Hello, my name is Corben Eastman. I'm an intern with the University of Wyoming's Advanced Research Computing Center. Today, I will be talking about a project that I've been working on this summer with ARC, titled Mount Moran Metric Collection and Presentation. For ARC, monitoring usage of HPC systems is crucial to making future decisions on hardware and software, support, and ultimately to provide better systems. To do this monitoring, my objective was to develop a set of scripts or tools to collect metrics on Mount Moran, the University of Wyoming's flagship supercomputer, and then to display those metrics in an easy-to-digest way. The metrics themselves were retrieved in several ways. General user and account information came from ARC's Lightweight Directory Protocol Server, or LDAP server. The core hours used on Mount Moran by each user and account were retrieved using a utility called saccount from the simple Linux utility for resource management, or Slurm toolset. Slurm is the job management software used by ARC, and it keeps a history of jobs ran on Mount Moran. saccount can retrieve these jobs, and parsing on its output was done to get the total number of core hours used by user and account over a specified time period. College information for users was retrieved from the University of Wyoming's administrative LDAP server. Finally, login information on Mount Moran was retrieved from a log file and parsed using Linux's last utility. Further parsing was done in the scripts. All of the code is written in Python. The bar plot and pie charts were generated with matplotlib, an open source plotting library for Python. The network plot of users and accounts was generated with Gephi, an open source network and visualization tool. To get the data into Gephi, CSV files are generated with the Python script, and then imported into Gephi. Some further manipulation was done to color the nodes, size them, and sort them. All the data necessary to do this is in the CSV files, and it's fairly trivial to do this with Gephi using that data. Now for the results. A quick note, these plots and visualizations are examples of the outputs generated by the script, or Gephi and a script. The scripts used to generate these plots are the actual objective of this project. Most administrators are familiar with understanding and analyzing bar plots. Providing this simple format can be useful to them in their decision-making process. This bar plot shows the number of users per college for colleges in the university that actually have users on Mount Moran. In the script, colleges with no users can also optionally be displayed on the plot. Unfortunately, most undergraduate students' colleges can't be identified through LDAP, so they have their own category. Next, we'll see a visualization of users and accounts on Mount Moran. Accounts are groups of users. The circles, or nodes, represent users and accounts, and arrows can be seen showing the users in accounts and how those users connect to other accounts on Mount Moran. This visualization makes connections to different accounts through users stand out easily. Nodes representing users are the smallest size, and their size is constant. Nodes representing account size increase with the number of users that account has. The color of each node corresponds to the CPU time used on Mount Moran in the last year by that user or account. As the legend shows, red represents more CPU time used, and blue represents less. The nodes are then sorted by the college that the account goes with. Finally, these two pie charts show login information. The chart on the left displays the number of active users versus the number of inactive users. By default, users that have logged into Mount Moran in the last 31 days are considered active, but the time period can be changed when the script is run with a command line argument. The chart on the right displays the number of logins from campus versus the number of logins from off campus. In conclusion, I wrote several Python scripts to make it easy to collect metrics about the use of Mount Moran, the University of Wyoming's premier supercomputer, and then displayed them in easily digestible ways. Using these metrics, the system administration strategies used on Mount Moran can be adjusted to better fit how it's being used and the user's needs. Also, those metrics can be taken into account when making any software or hardware upgrades to Mount Moran, or any decisions on the future of the University of Wyoming's HPC resources in general. Overall, I hope these tools and the metrics generated by them prove to be useful for ARC and the rest of the University of Wyoming. I would now like to acknowledge the following people for assisting in various ways: Wally Ciccone, Troy Axthelm, Jeremy Clay, Jared Baker, Dr. Dane Sko, Uday Midha, and Dylan Perkins. All of the scripts written for this can be found on the ARC GitHub under a project called ARC_metrics. The URL can be seen here. Thank you for watching.